Hi. So in this problem, we'll be looking at a geometry question. This is about incircles and excircles and triangles. And this type of problem typically appears in Olympiads and sometimes even in JEE Advanced. So let's get into it. Let ABC be an isosceles triangle with AB is equal to AC. D is a point on BC such that the incircle of triangle ABD is congruent to the excircle of triangle ADC tangent to DC. And basically, then we have to compare the radius of the incircle to the length of the altitude of triangle ABC drawn from B. Right? So, in order to approach this problem, we need to understand the second line of the question. This sentence is crucial. So, let's try and understand that with a figure. I'll draw a triangle here. This is an isosceles triangle, triangle ABC, and then AB is equal to AC. And I have to mark a point D such that, let's label it first. This is D and extend it a little bit. I have a triangle ABD, and in that I have to draw the incircle, right? So incircle of this would be like this, touching all the three sides. This is roughly my incircle here for triangle ABD. Now I also have to draw the excircle of triangle ADC, right? So ADC excircle, the excircle tangent to DC. So first I should extend the sides here. And once I extend the sides, if you recall, excircles are drawn by drawing the external angle bisectors. So you will draw an angle bisector like this here, and you will draw another angle bisector near C, but it's an external angle bisector like this and like this. And the intersection point will give you the X center. And then you will draw the figure, which will a circle, which will basically touch the side DC, right? So I will just draw a rough figure by hand. And let's say this is the circle here that touches the side DC. So it is tangent to DC. This is my X circle, and this is my incircle, excircle of triangle ADC. Now, according to the question, these two circles are congruent. These two circles are congruent means their radius will be same, right? Their radiuses are equal. Now, if that is the condition, we have to somehow make use of those conditions. So let's approach this problem by first analyzing what is the length of AD. We need some estimate of the length of AD because we'll be using that to sort of connect it to the areas of the triangle, right? So in case you are aware, maybe you are not aware, you have Stewart's theorem, which can give you the length of any line from a vertex to the opposite side, right? So Stewart's theorem, for those who don't know, I will explain on the next page. So Stewart's theorem can be shown and can be proved by simply cosine rule. But right now I'll show you the result. I have other videos on the channel where I have explained Stewart's theorem. So right now I'll just tell you the result. So this is AD, and I want the length of this AD, right? So let's call it D. And let's say D divides the BC side in two parts. BD has length M and BC has length N, right? And total length here, BC, is A, which is basically M plus N, right? And this side, the side opposite to angle B is called small b, and the side opposite to this is C. Now, Stewart's theorem says, and the way to remember it is dad plus man is equal to CNC plus BMB. Okay? Now, what is this dad plus man stuff? Dad is simply DAD. So D is what? AD, right? This is D square A. This is just a mnemonic that helps you memorize Stewart's theorem. But now I'll write it properly. This is MNA. This is C square N plus B square M, right? So what is D? D is AD square, and A is what? A is the length of BC. Okay, so I'll write BC plus MN. MN is BD into CD. And what is A? A is again BC is equal to C square N. C square N will be AB square into N, which is CD, plus B square M. B square M will be AC square into M is BD, right? So we have this relation from Stewart's theorem. Now, if you recall, the triangle was isosceles. So AB is equal to AC, right? AB is equal to AC. So we can say this is AB square and this is also AB square, right? So AB square can be taken common and you get CD plus BD here. And what is CD plus BD? CD plus BD, you will realize, is BC. AB square into BC comes on the right hand side. And what was on the left hand side? This expression. Notice that there is BC in every term, right? So BC can get cancelled now, and you will get AD square minus AB square plus BD into CD is equal to 0. Or you can just have written AD square plus BD CD is AB square, right? So we'll keep that condition in mind. Basically, this gives us the length of AD square. AD square is coming out to be AB square minus BD into CD. Keep that condition in mind. We'll utilize this condition later in the problem. This is coming directly from Stewart's theorem. And if you want to understand how Stewart's theorem works, it is just cosine rule here with this angle and with this angle. And these angles are supplementary. So cos here will be negative of cos here. Apply cosine rule and equate them, and you will get Stewart's theorem. Okay. So hopefully that will help you understand how we are getting this, right? Now, in a triangle, if you have an incircle and an excircle, there are a couple of results from properties of triangle that everyone should be aware of. So I will just outline them here. Let's say this is an excircle. This big circle outside is an excircle opposite to A, right? A, B, C. This is an incircle, and we have area of the triangle is equal to R times S, where this is the radius of incircle, and S is the semi-perimeter. This is a standard result that is shown in any standard book. You should usually refer to S.L. Loney for such results. Chapter 12 and chapter 15 of S.L. Loney. That is the best place to understand all this. The other result that I want to say is the area of the triangle can also be given in terms of the x radius. This was R1. This is x radius. This is in radius. Area of the triangle can also be written as R1 times S minus A. Why do you have S minus A? Because it is opposite to the A. The X circle is opposite to A. So we have S minus A here. And R1 here is the radius of that X circle. So this is again a standard result from S.L. Loney. I will not bother to prove these results. These can be shown in any standard book, right? Now, why am I doing all this? What we will do, go back to now, is the problem that we had. Right? We had an isosceles triangle. We had an incircle. We had an excircle, right? So we had this B, and there was an excircle here. There was an incircle here, and there was an excircle here. And the circles were congruent. Congruent means they had same radius. So this is A, B, C. This is D. So triangle, this radius was, let's say, capital R, and this radius was also capital R. That is what it means when you say this circle is congruent to this, right? Now let's look at that now. We have area of triangle ABD. Area triangle ABD is equal to, ABD is this triangle. I have an incircle radius here. So that will be R into S. So it will be R into S. S is semi-perimeter. So semi-perimeter of this triangle would be AB plus BD plus AD by 2, right? That is semi-perimeter. Now what is area of triangle ACD? Area of triangle ACD can be written in terms of the x radius by using the formula del is equal to R1 S minus A. So x radius for triangle ACD is also R. So we'll say R. And now I have to write S minus A for this triangle ACD. So that will be AD plus CD plus AC by 2 minus A, and A is this side. A is the CD side for this, right? What am I doing here? I'm just using my properties of triangle results to write the areas of these two triangles, right? So I'm using this formula in the second case, and I'm using del is equal to RS in the first case, right? So this can simplify now like this. It becomes AD plus AC minus CD by 2, right? That is area triangle ACD, correct? Now we have two results, area ABD and area ACD. Now think of the triangle. These two triangles have the same height, right? Because they are on the same base and they have the same vertex A. So if you drop an altitude here, the height is same, but their bases are different. So you can say by basic geometry that area triangle ABD by area triangle ACD will be half into height into BD divided by half into height into CD. Or since the height is common, we'll get it is in the ratio of BD to CD, right? The areas of these two triangles are in the ratio of their bases, right? Great. We already have an expression for the area here and the area here. We'll use those two expressions and write that it is equal to BD by CD, right? So R by 2 and R by 2 will cancel when I divide. So what I'll end up getting is AB plus BD plus AD divided by AD plus AC minus CD is equal to BD by CD, right? This is the expression that I'm getting. I'm using these two area expressions and I'm dividing and saying that the ratio should be BD by CD, right? Now, again, I will use the fact that AB is equal to AC here. So the expression becomes AB plus BD plus AD divided by AB plus AD minus CD. I'm just replacing AC with AB here is equal to BD by CD. Now we have to cross multiply and simplify this expression, right? So we'll say AB into CD plus BD into CD plus AD into CD is equal to AB into BD plus AD into BD minus BD into CD, right? So bring the minus BD CD in this side and you will get 2 times BD into CD and bring everything else on the other side, right? Every other term on the other side. So you will end up getting, here we can say BD common, you'll get AB plus AD, and then you'll say minus this term and this term, I can take CD common and it will be AB plus AD. Can you see that I can take this AB plus AD common in both? So I'm taking it common here and I'm taking it common from these two terms, right? So eventually now you will end up with this relation. I will just write it on top here. You just write it here. You end up with the relation 2 times BD into CD, 2 times BD into CD is equal to AB plus AD multiplied by BD minus CD, right? AB plus AD multiplied by BD minus CD. And now recall that we had applied Stewart's theorem earlier and we had gotten BD into CD is equal to AB square minus AD square. Earlier we had gotten this by applying Stewart's theorem in the triangle ABC here, right? So I will use that result now here and what I will get is 2 times AB square minus AD square is equal to AB plus AD multiplied by BD minus CD, right? And AB plus AD will cancel from here. AB plus AD will cancel from here, one factor, and you will end up with 2 times AB minus AD will be equal to BD minus CD, right? So we end up with this result, BD minus CD is equal to 2 times AB minus AD, right? Now we take a different approach and we say that area of triangle ABC is equal to half into height B into AC. What do I mean by this? If I have triangle ABC here, from B I can draw an altitude on AC and this can be written as HB. This is the area of the triangle, right? So AC here is there and HB is there, and this is also equal to triangle ABD plus triangle ACD, right? So D was somewhere here, and triangle ABD area plus ACD area is also equal to the area of the triangle, right? So we can say HB into AC is twice of triangle ABC area plus not ABC, ABD area plus twice of triangle ADC area, right? Great. And we already had written area of these triangles in terms of R and all. So if you use those expressions, twice of the area will be ABD will be R times AB plus BD plus AD plus R times here, it will be AD plus AC minus CD. So if you take R common, we will get AB plus BD plus AD plus this and this, right? So Think about it. This is AB plus AC. So AB and AC are identical because it's isosceles triangle. So we can write 2AB. We have removed this, we have removed this. And then you get BD minus CD plus BD minus CD. And you also get this I have removed and this I have removed. And you get AD plus AD. So you get 2AD, right? Correct? And now just now we derived BD minus CD was equal to 2 times AB minus AD, right? In the previous screen, we had done this derivation, right? When we had compared the areas of the two triangles and written it as BD by BC and cross multiplied and gotten this using Stewart's theorem, right? So I will use that result here now, and I will say this is R times 2 times AB plus 2 times AB minus 2 times AD plus 2 times AD. So AD gets cancelled and you get 4R times AB is equal to HB into AC, right? And AC is equal to AB, so you get HB is equal to 4R. Therefore, R is equal to 1 by 4 times of HB, right? So the question was asking us for the value of K, right? Where radius of the incircle was being compared with the length of this height. And the ratio K is coming out to be 1 by 4. That is your answer. And that's how you solve this problem. Now, keep in mind that there are several concepts that were used here. First thing was Stewart's theorem to get a sense of the area, the length of AD. The second thing was area of triangle ABD and area of triangle ACD. Both were written in terms of the two formulas, del is equal to RS and del is equal to R1 into S minus A. Then the next condition was we compared the areas of ABD and ACD and said that the ratio of the areas will be equal to the ratio of their bases. And we used that ratio to cross multiply and simplify and get a condition, right? In there, we use Stewart's theorem conditions also. Then finally, we are saying area of triangle ABC can be written in terms of triangle ABD plus triangle ACD and also written in terms of half into HB into AC. And finally, this is the solution. Once you simplify all of this, you will get the answer. So this is a typical first round or second round Olympiad problem. However, things like this have been asked in JE as well in recent years. You need to be aware and you need to be able to analyze questions. The question can be very simply stated, but if you are not on the right track, it is difficult to solve. If you try to use random formulas, it will be really difficult. You have to use the right set of tools when you are trying properties of triangles questions, right? Hopefully you learned something from this video. Please feel free to share your comments, or if you have any other doubts, there is a Google form link in the description. You should use that and send me your maths or physics doubts. I'll try and make content around that to help you. Also, please like the channel, subscribe to the channel, and stay tuned for further videos. I'll see you next time.